Hello viewers, today we are going to discuss glycogenolysis or glycogen breakdown. Glycogen and lysis, glycogen lysis or glycogenolysis. The breakdown of glycogen to glucose is called as glycogenolysis. Let us see the definition and where this occurs and how it occurs. Definition of glycogenolysis: the breakdown of glycogen to glucose is called as glycogenolysis. It is a catabolic pathway of glycogen. It takes place in liver and muscle cells, and in these liver and muscle cells, it takes place in the cytosol region. Starting material of the glycogenolysis is glycogen, and end product is glucose or glucose 6 phosphate. So, especially you can see end product glucose in the liver and glucose 6 phosphate in the muscles. These are the possible end products depending upon the organ. Next is we are going to see the pathway glycogenolysis. In the beginning glycogen, and in the end you can get glucose or glucose 6 phosphate in the muscles. So first glycogen, which is a polymer of glucose, homopolymer of glucose, having branched chain at 8 glucose molecules. One by one glucose is going to be released from the glycogen, and during this process glycogen phosphorylase and debranching enzymes with the help of inorganic phosphate is going to release one glucose from the big chain of or long chain of glycogen, and that glucose is released in the form of glucose on phosphate. This glucose on phosphate further with the help of phosphoglucomutase is converted to glucose 6 phosphate. The glucose which is present in the first carbon atom is transferred to sixth carbon atom by mutation or change, and hence the enzyme name phosphoglucomutase. And this glucose 6 phosphate will undergo glycolysis in liver cells or otherwise in muscle cells or otherwise in liver cells. Glucose 6 phosphate can be converted to glucose by enzyme glucose 6 phosphatase enzymes. So this is the pathway of breakdown of glycogen and glycogen to glucose on phosphate. The one glucose is released, and that glucose on phosphate is converted to glucose 6 phosphate, and further it is phosphate is removed from glucose 6 phosphate to produce glucose and in the liver, whereas in the muscle this enzyme glucose 6 phosphatase is not present, and hence it is going to enter glycolysis, and like glucose 6 to fructose 6 you can see in the left side arrow mark to glycolysis, that is in the muscle cells. You can write above the arrow mark in the muscle, whereas glucose 6 phosphate to glucose in the down arrow mark it is in the liver. Now the significance of glycogenolysis. Glycogen breakdown or glycogenolysis is a very important pathway because it provides glucose during deprived glucose condition in the body. Whenever the less glucose is there, the stored glycogen is going to release glucose by glycogenolysis. Hepatic glycogenolysis, that means it in the liver the glycogenesis takes place in order to maintain blood glucose level, and in the muscle glycogenolysis takes place for the provision of energy. Whenever there is vigorous muscular activity to get the energy, the muscle derives glucose from glycogenolysis for energy production. Regulation of glycogenolysis. Glycogenolysis, either to break or not to break glycogen, is regulated by the enzymes, and the enzyme is glycogen phosphorylase is the regulatory enzyme of glycogenolysis. Whenever the glucose level is less, this enzyme will get activated. The activated enzyme is going to stimulate the glycogenolysis and thereby releasing the glucose from the glycogen and maintaining the glucose level. This is in the low glucose level than the normal values. Whenever the glucose level is high in the blood, there is no need of further glucose, hence this enzyme will get inactivated and it is not going to perform glycogenolysis, thereby stopping the release of glucose from the glycogen. Thereby it can maintain the glucose level in the body. Glycogen phosphorylase is a regulatory enzyme. Next is glycogenosis. So you should keep in mind that Glycogenesis is different, glycogenosis is different. Glycogenosis means also called as glycogen storage disease. The inherited genetic defects related to glycogen metabolism. The defects that occurs in the glycogen metabolism is going to cause a condition called as glycogenosis or glycogen storage disease, either in the synthesis or in the breakdown process. If any defect takes place, or either in the synthesis process or breakdown process, if it is going to uh, have disorders, it leads to glycogenosis or glycogen storage disease. These genetic diseases are characterized by deposition of abnormal type of or abnormal quantity of glycogen in the tissues. So either in the synthesis of or partial production of intermediates, or in the glycogen breakdown also, off pathway taking place and certain enzymes are not absent, certain enzymes are absent, and further the pathway is not going to perform, then it goes going to leads to deposition of glycogen in the tissues. Glycogenosis are group of genetic diseases that result due to enzyme defects of glycogen metabolism. There are several types of glycogen storage diseases. In each type, there is a deficiency or low activity of a particular enzyme. So, either in the synthesis or either in the breakdown, every step involves enzymes, and that enzymes are going to perform the particular step of that process, either synthesis or breakdown. If that enzymes are in having defect, it leads to glycogenosis. So let us see what are the type of glycogenosis or glycogen storage diseases, and what are the enzymes responsible for, and what are the complications. The glycogenosis, there are six major types are there. Type 1 is called as von Graecker disease, type 2 is called as Pompe disease, type 3 is called as limit dextrinosis or Cori disease, type 4 is called as amylopectinosis or Anderson disease, and type 5 is called as McArdle syndrome, and type 6 is called as Hers syndrome. So let us see these glycogen storage six type of disease major types. What are the reason for this? This is in detail you can see, and what is the reason and what is the complication, and the same thing is there in the tabular column type, so that it will be easy for you to go through it. So let us see in this first in detail, and then we'll go for tabular column method. Glucose 6 phosphatase in type 1 von Graecker disease, glucose 6 phosphatase is absent in the liver, and failure of glycogenolysis leads to hypoglycemia, and ketosis. So, if in the liver glucose 6 phosphatase is absent, then there is no glycogenolysis in the liver, and thereby there is hypoglycemia, and it cannot be going to be bring it to normal, and due to lack of glycogenolysis and ketosis takes place. There is abnormal accumulation of glycogen in liver, leading to hepatomegaly. So glycogen go on storing, it cannot be used because due to lack of this enzyme glucose 6 phosphatase, and excess glycogen storage is going to make the liver big or large. Mega means you can see hepato means liver, mega means big, leads to hepatomegaly. This accumulated glycogen in liver is not useful. So body is storing glycogen, but body cannot utilize glycogen. It is a having problem in maintaining glucose level, and it leads to hepatomegaly. So type 2 is called as Pompe disease. It is due to lysosomal alpha 1 for glucosidase enzyme absent in the body, and lysosomes which are going to degrade glycogen with the help of this alpha 1 for glucosidase is absent. Thereby the absence of this enzyme makes the glycogen accumulate in the lysosomes, and this type is called as also called as lysosomal storage disorder or Pompe disease. Type 3 is called as limit dextrinosis or Cori cycle. In this, the debranching enzyme, since glycogen contains branching at every 8 glucose molecules, alpha 1 4 and alpha 1 6. 1 6 is the branching enzyme. This debranching enzyme is going to cut the alpha 1 6 linkage at the branching point. If this enzyme is absent, it leads to accumulation of polysaccharide called as limit dextrins, and thereby causing type 3, and type 4 is called as amylopectinosis or Anderson disease. The core is disease or Anderson disease. These are the name of the persons who discovered these diseases, hence their names are kept. So type 4 is called as Anderson disease. Branching enzyme is absent. This branching enzyme you can see in glycogenesis. Glucose after 8 molecules it will have branches in glycogen, and alpha 1 4 glucose is formed by branching. This branching enzyme is absent, whereas in type 3 debranching is absent, and in type 4 branching enzyme is absent and leads to accumulation of polysaccharide with few branch points, and death occurs due to cardiac or liver failure in the first year of life. This is very um, dangerous condition. Amylopectinosis can cause various type of life complications. Type 5 is called as McArdle syndrome. Muscle phosphorylase is absent. The phosphorylase enzyme in the muscle is absent. Glycogen accumulates in the muscle. Patients with this disease exhibit a markedly diminished tolerance of exercise. They don't want to go have physical exercise. There is a very little bit lactate formed after exercise. So muscle phosphorylase is absent. It leads to McArdle syndrome. Type 6 is called as HER syndrome. It can be seen in lack of liver phosphorylase. You can see type 5 is muscle phosphorylase, whereas type 6 is liver phosphorylase. Very much same, but the location is different. The type 5 is muscle phosphorylase, type 6 is liver phosphorylase. Enzyme is different and also their organ is different. Glycogen accumulates in the liver. Failure due to glycogenolysis leads to hypoglycemia. In this, glycogen is not going to be broken down, hence it leads to hypoglycemia and other complications. So these are the 6 types of glycogenosis or glycogen storage disease.